Windows 10 2006 presents color spaces. For this example, I'm gonna use this image.
Don't forget to credit me for it, okay?
Okay, Amy. Anyways, let's start. The most common one, RGB. This is how it looks like. R is for red, G is for green, and B is for blue. This color space can show up to approx 60 million colors. Here's the actual values displayed in monochrome. CMYK. This is a color space used normally on printing and pigments, and it's called the subtracted color model, being the opposite of RGB, which is the additive color model. C is for cyan, M is for magenta, Y is for yellow, and K is for key. Although key is also known as black. Here are the values of each one: HSV, HSL, and HSI. Let's start with HSV. This is how it looks, decomposing it. HSV stands for hue, saturation, and value. This one is common when changing colors on Aucune. For the hue, it's more easier than using RGB since we can choose from a basic range. Next, we got HSL, which is more common than HSV. HSL stands for hue, saturation, and lightness. The saturation here is different from HSV. This one is widely used for digital painting, editing, etc. And finally, we got HSI. This one is the least common one with the use of basic tools. HSI stands for hue, saturation, and intensity. Those three color spaces made more easier, especially for people having trouble on using RGB. LUT. This color space is designed to approximate human vision. L is for perceptual lightness, A and V for the four unique colors of the human vision, red and green for A, and B for blue and yellow. The positive A represents red, and the negative A represents green. The positive B represents yellow, and the negative V represents blue. Here's what LCH looks like, with the C representing the chroma and the H representing the hue. The hue is different from HSV, HSL, and HSI. YCBCR. This is a color space which is used as a part of the color image pipeline in video and digital photography systems. Y is for luma, CB and CR are the blue difference and red difference chroma. This is sometimes abbreviated to YCC. Also, this color space is used with digital images, YUV. This is a color space found in the PAL analog color TV standard. And usually, the videos are not stored in RGB but this color space. Y is for luma, U and V are two chroma components corresponding to blue and red respectively. This one is similar to YCBCR, but it's actually different. XYZ. Before we go on the info, I just wanna say I only got them in monochrome due to lack of things to get in color. This color space is the first color space ever to exist in 1931. This one is the essential tool that provides the foundation for measuring color for industry, including inks, dyes, and paints, illumination, color imaging, etc. X is for the mix of the three CIE RGB curves chosen to be non-negative. Y is for the luminance, and Z quasi-equal to blue. Still widely used, although it is not perceptually uniform in relation to the human vision. And lastly, YIQ. This color space is used by the analog NTSC color TV system. I stands for in phase, while Q stands for quadrature, referring to the components used in quadrature amplitude modulation. Y represents the luma. I and Q represent the chrominance information, with I indicating red side contrast and Q indicating magenta green one. Very few television sets perform true IIQ decoding due to high cost of such an implementation. And that's all of the color spaces I gave. I made LUTs out of those except for RGB. The idea was taken from Cube 9000, the one who made YUV, CMYK and RGB color splitters using a video software. If you wanna make color splitters like he did, I'll leave the color splittings LUTs in description. See you guys later.